Let's move on to another one, that is question number 14. If R, a relation given like x square plus 3y square is less than or equal to 8 inside the ellipse or on the boundary, is a relation on the set of integers, then the domain of R inverse. So we are talking about the values for y. So let's see, if you draw an ellipse like this, correct? So you can also draw, if you want, the coordinate system like this. Correct. Now, what the question is talking about? Integers. When you say in this ellipse y is 0, x is plus minus 2 root 2. When you say x is 0, y is plus minus root of 8 by 3. Root of 8 by 3. 8 by 3 meaning 2.67. It's a square root. So obviously some value between 1 and 2 is there. Correct. We are looking for y. So what we can observe here? 0, 0. 1, 0, 2, 0. This one, we can clearly see and check some values over here, that these are inside. You can see this point is 3, 2. This point is 2, 1. When you put here 2, 1, you can see this is 4 plus 3, that is 7, which is less than 8. So yes, clearly it is inside. When this point is inside, so obviously all reflections you can see. So these are the points. Now what the question is? Simple one. Now we have reached at our conclusion. Domain of R inverse, we are looking for the values for y. Correct? What these are? Yes, it is -1, 0 and 1. I'm sure this simple question is clear. So let's mark as the required result option number 3. Let's move on to the another one, question number 15. Let A be a 2 by 2 matrix with entries from 0 and 1 only. Determinant A is non-zero. Consider the following two statements. If A is not I2, that is identity matrix of order 2, then determinant A has to be -1. From these entries, if A is not I2, then determinant A has to be -1. Can you imagine this kind of matrix like 1, 1, 1, 1? Clearly this is not I2. The value is also not -1. So yes, this statement is false. Next, if determinant A is 1, then trace of A is 2. Determinant A is 1. Clearly when you are saying determinant A is 1, diagonal entries are definitely 1 because 0 cannot be there. Here you can put any value, 0 or 1. Trace of A meaning sum of entries in the diagonal. So yes, trace of A has to be 2. This is true. Let's check out from the options. Options, if you look at it, you can see that P is false, Q is true, given as option number 4. So let's mark as the required result for another simple question, this time from determinant matrices. Right? So let's consider another one, question number 16. The plane passing through these 2 points and parallel to this given line also passes through the point. 4 options are given. Question from 3D. Let's try. Let the plane be A into x minus 1 plus B into y minus 2 plus C into z minus 1 is equal to 0. It is passing through another point 2, 1, 2. So let's pass it. This is A minus B plus C is equal to 0. This is clear. Now this line, we can rewrite this line as x upon 3 is equal to y by 2 is equal to z minus 1 upon 0. So what are the direction ratios of the line? 3, 2, 0. Clear? Plane passing through these 2 points is parallel to this line. A plane is parallel to a given line, meaning normal to the plane is perpendicular to this line. Normal to the plane, we know the direction ratios are ABC. It is perpendicular to the line. Normal to plane is perpendicular to the line, meaning that 3a plus 2b is 0. So let's say this is equation 2, this is equation 1. Now solving 1 and 2 from 1 and 2. Either we can solve by cross multiplication method, or we can say since we have b equals minus 3a by 2, substitute it here. B is minus 3a by 2. That means you have a plus 3a by 2 plus c is equal to 0, giving you c in terms of a as minus 5 by 2a. Right? So just combine and try to write ABC here. So this implies that a upon 1 equals b upon minus 3 by 2 equals c upon minus 5 by 2. Or we can further rewrite it as simplified form a upon 2 is equal to b upon minus 3 equals c upon minus 5. So ratios, that is direction ratios, it is 2 minus 3 minus 5. Put it in this equation of plane, correct? Therefore, plane is 2 into x minus 1 minus 3y minus 2 minus 5 into z minus 1 is equal to 0. Just simplify to get the equation of plane in the final form. This is 2x minus 3y minus 5z, and what's the constant? Minus 2 plus 6, that is plus 4, plus 5, that is plus 9, is equal to 0. So 2x minus 3y minus 5z plus 9 equals 0 is the plane. These are the points, right? Let's write the equation of plane over here. 2x minus 3y minus 5z plus 9 is equal to 0. When you try to substitute these points one on one, you can clearly see when you put minus 2, 0, 1 over here, this becomes minus 4, 0, minus 5 plus 9, that is 0 equals 0. So the correct answer for this question is obtained as option number 2. So let's mark and mention as the required result. So I'm sure this question is clear. The correct answer for this question is option number 2. Let's move on to the another one.